Hello everyone, my name is Surabhi Kaushik of Department CSCAML, studying in the section B. Today I am going to discuss about the topic circuit theory in a unified circulum. The basic concepts of a circuit theory. What is the definition of circuit theory? An electric circuit is a network consisting of a closed loop giving a written path for the current through a switch. When the switch is activated, the load activities and the current gets a path to complete the circuit from a high potential level to the opposite low potential level. The applications of circuit theory, power management, signals between subsystems, possible analog data types, electrical laws. Electric circuit theory follows a number of electrical laws. There are around six laws that follows: Kirchhoff's current law, Kirchhoff's voltage law, Ohm's law, Norton's theorem, Thevenin's theorem, superposition theorem. The basic electronic components and their applications. First one is resistor. A resistor is a component that resists the flow of current. It's one of the most basic components used in electronic circuits. Resistors come in a variety of resistance values and power ratings. Second one is capacitors. Next to resistors, capacitors are probably the second most commonly used component in electronic circuits. A capacitor is a device that can temporarily store an electric charge. Capacitors come in several different varieties. The two most common being ceramic disc and electrolytic. Third one is diode. A diode is a device that lets current flow in only one direction. A diode has a two terminals called the anode and the cathode. A diode is a device that lets current flow in only one direction. A diode has two terminals called the anode and the cathode. Current will flow through the diode only when positive voltage is applied to the anode and the negative voltage to the cathode. Fourth one, transistor. A transistor is a three-terminal device in which a voltage applied to one of the terminals called the base can control current that flows across the other two terminals called the collector and the emitter. Integrated circuits. An integrated circuit is a special component that contains an entire electronic circuit completely with transistors, diodes, and other elements all photographically etched onto a tiny piece of silicon. Integrated circuits are the building blocks of modern electronic devices such as computers and cell phones. In a unified curriculum encompassing circuit theory, students devise into the foundational principles and applications that form the backbone of electrical engineering. This comprehensively study begins with an exploration of basic electrical concepts, including voltage, current, resistance, and power. Understanding Ohm's law becomes fundamental as students learn the relationship between these key parameters. Moving beyond the basics, the curriculum introduces circuit analysis techniques. Students explore methods like nodal analysis and mesh analysis to analyze complex circuits. This analytical foundation is a circuit for designing and troubleshooting electrical circuits, whether they are simple or intricate. As the curriculum advances, students encounter various circuit elements such as resistors, capacitors, and inductors. Understanding their behavior within circuits is essential for predicting and manipulating electrical signals. The study of transient and the study state responses deepens students' insights into circuit dynamics, preparing them for real world applications. The curriculum integrates theoretical knowledge with practical skills, introducing students to circuit simulation tools. This hands on experience allow them to simulate and analyzing circuits, gaining valuable insights into their behaviors before physical implementation. This approach aligns with the modern engineering landscape where virtual prototyping is a key aspect of the design processing. One of the key principles is a circuit theory is Ohm's law, which states the current passing through a conductor between 2 points is directly proportional to the voltage across 2 points. The simple relationship serves as a fundamental building block for more complex analysis. Kirchhoff's law, another cornerstone for circuit theory, offers a systematic method for analyzing complex circuits. Kirchhoff's current law states that total current entering a junction in a circuit is equal to the total current leaving the junction. Emphasizing the conservation of charge, Kirchhoff voltage law asserts the total voltage around any closed loop in a circuit is equal to the sum of the voltage drops within a loop. Thevenin's theorem and Norton's theorem provide powerful tools for simplifying complex circuits into equivalent circuits, making analysis more manageable. Thevenin's theorem states that any linear circuit can be replaced by any equivalent circuit consisting of a voltage source in a series with a resistor, simplifying the circuit while preserving its external behavior. Superposition is a principle used in circuit theory that follows engineers to analyze the effects of individual sources in a multi-source circuit independently by calculating the contribution of each source separately and then summing the result. Engineers can determine the overall circuit's responses. Impedance is a crucial concept in circuit theory, especially in AC circuits. It characterizes the opposition that a circuit present to the flow of alternating current and includes both resistance and reactance. Capacitors and inductors introduce reactive components to the circuit, and impedance help account for these effects. And hereby I conclude. Thank you.